So in this video, we are going to attempt to match equations and graphs. We've sort of talked about how to get an equation from a pattern, and now we want to try to match them. So what we're going to do to show you how to do this, there's three graphs here, graph A, B, and C, and there are three equations, 3x minus 3, x plus y equals 3, and y equals 3x plus 3. And what we're going to do is we're going to try to fill in the table of values here. So you're used to that by now, I think. So we're going to plug in 0 first. So 3 times 0 minus 3, which gives us minus 3. And then 3 times 1 minus 3, which gives us 0. And then 3 times 2 minus 3, which gives us 3. So we want to see which of these graphs goes through 0 and minus 3, 1 and 0, and it looks like this is our candidate here because there's 0 and minus 3, there's 1 and 0, and then at 2 it's supposed to go through 3, and it does. So that graph B, is going to match this one. So we're going to say it's graph B. All right. For the next one, we're going to do the same kind of thing. So we're going to go 0 plus y equals 3. Okay, so what I'm going to do actually, to make it easier for myself, is I'm going to take this and I'm going to rearrange it to say that y is equal to 3 minus x. All right, so all I'm doing is bringing this x to the other side, or you can sort of look at it as going minus x on both sides. But that's going to allow me to go 3 minus 0 is 3, 3 minus 1 is 2, and 3 minus 2 is 1. So I'm looking for the point 0 and 3. Okay, so you'll notice that 0 and 3 is actually on both of these graphs. So that in itself doesn't tell me which graph it is, but the next point should, because the next point is 1 and 2. So on this graph, I'm at 1 and 2. On this graph, I'm at 1 and 6. So that one's not it. And then, of course, just to make sure, we go 2 and 1, does that fit? And it does. So this guy is graph A. And then, of course, by process of elimination, we know this is graph C. Okay, but we should check to make sure that it actually matches. So 3 times 0 plus 3 is the first one, and that gives me 3. Then 3 times 1 plus 3 gives me 6. And then 3 times 2 plus 3 gives me 9. So I just have to check. This goes through 0 and 3. We already know that. At 1, it's supposed to go through 6, which it does. And then at 2, it should be going through 9, which it does. So it checks out. Okay? So that's how we sort of compare the graph to the equation, is just use a table of values and see which one matches the points that we come up with. Now, a quick way is to pick 2 points from the graph instead of doing a table of values and going all the way through it, is to pick 2 points from the graph and put them into the equation and see if they work. Okay? And if they work, then we know that it is the correct equation. It matches the graph. Okay? So to show you that, we have y equals 2x plus 3. That's our equation, and we have this graph. So what I want to do, I'm going to identify this point. So that's the point 0 and 3. And then I'm going to identify this point, which is the point 1 and 5. Okay? And all I'm going to do is I'm going to test them. So 0 and 3, we're going to put y is 3, 2 times 0 plus 3. Okay? Because x is 0. So that gives me 3 is equal to 3, so that works. That checks out. And then I'm going to check the other one that I selected, which is 1 and 5. And so I'm going to go y is 5, 2 times x is 1 plus 3. And I'm going to see if that works. And we get 5 equals 2 plus 3. So 5 equals 5, and we would say, yes, that is also good. So because of that, we know that this is the equation that matches that graph. Now, you might say, well, why did you pick 0 and 3 and 1 and 5? Why didn't you pick some other points? You could. Okay, you can pick any points, but what I would suggest is don't pick points that aren't on an intersection of the grid. So that one is, this one is, right? This one is, but I wouldn't pick something like this because then you're guessing. So pick ones that are actually at numerical values of x and y that are nice numbers. Okay? So we want to do the same thing here, match the following equations to the graph, but we're just going to pick 2 points. Okay? So if I do this one, I'm going to pick this point and this point. This is the point 0 and 3, and this is the point 1, 2, 3, and 0. Okay? So if I choose those 2 points for that graph, and then let's say, again, I'm looking for grid points, so this is the point 1 and 0, and like this one goes through 2 and 3, okay? And then for this guy, this goes through -1 and 0, and then 0 and 3, okay? So again, I'm making a choice. You can choose any other points as long as they are on grid lines, right? So that's not the only point I could have picked. I could have picked those 2 as well. So all we're going to do is test these points in these equations. So y equals 3x plus 3. I choose to see if this works with 0 and 3. So if this is 3, then I go 3 times 0 plus 3. I say, does that work? And I say, yes, it does, because that would mean that 3 is equal to 3. Then I test 3 and 0. So that would be 0 is equal to 3 times 3 plus 3. And I automatically say, no, that doesn't work. So that means it's not that one. Okay? Then I go to here. I say, does 0 plus 3 equal 3? Yes, it does. Okay, again, I'm using these points. And then does 3 plus 0 equal 3? We say, yes, it does. So that means that this equation is this graph. Okay? So once we've decided that, then we only have to test in the other 2. I'm just going to erase the testing because we're going to test this another set of points here. But I don't have to test in the middle one anymore because I've already done that. So then let's do this one, 1 and 0. So I plug in 0 for y is equal to 3 times 1 plus 3. And we say, no, that doesn't work. So that's automatically out. So then we try it here. We say, does 0 equal 3 times 1 minus 3? And we say, yes, it does. So that one works. And then we just test 2 and 3 to make sure. So 3 is equal to 3 times 2 minus 3. Okay, I'm just testing this point now. And that gives me 3 is 6 minus 3. We say 3 is equal to 3, so it works. So this equation then is that graph, which leaves, of course, this equation is this graph. And we know that 0 and 3 worked already because we tried it in the first question. So if we just try the other one to make sure, and again, you don't have to in this case in the sense that you're told that they have to match, but if I try -1 and 0, I get 0 is equal to 3 times -1 plus 3. If I test this point, okay? Again, x is -1, y is 0. So if I do that, I get 0 equals -3 plus 3, and that means that 0 equals 0. And that is the case. That's true. So we can match the graph using a table of values, which we talked about back up here, right? Or you can match the graph by picking 2 points that are on the graph and plugging them into the equation. So again, we're trying to match each equation to the appropriate graph. Now, what you'll notice is there's a couple of things that will make this a little bit easier. As soon as you know that one point doesn't work, you're done. Okay, so if I pick this point right here, which is -1 and 2, if I plug -1 and 2 into here, I would get 2 for y is equal to 2 times -1. And that means 2 equals -2. And we say that's not true. I automatically know this green line that's indicating this graph, that is not this. Okay, I can plug it in here, and I get -1 and 2 again. All right, so that means 2 is equal to -2 times -1. That actually does work. I get 2 equals 2. And over here, if I plug in -1 and 2, I would say 2 is equal to -1. We say that's not true. So that means this graph is that equation. Okay, it's y equals -2x. Then if I pick another point, so let's say I pick a point on the red one. So this is the point here, and it's 1, 2, 3, and 2. So it's 2 in the x and 3 in the y. I believe, if I'm counting correctly. No, sorry, it's 2 and 2. No, it's 2 and 4. I'll learn to count. I missed, right? 1, 2, 3, 4. Yeah, so it's 2 and 4. So I try that one now. We knew this one didn't work, so now we try 2 and 4. So I say 4 would equal 2 times 2. We say, is that true? 4 equals 4. Yes, that is true. Over here we try it, and we get 4 is equal to 2. And we say, nope, that's not right. So that means this red graph is this equation. Okay, it's y equals 2x. And that, of course, leaves the blue one to be y equals x. If you want to check that, just choose a point here. It's -2 and -2, right? We know it doesn't work in the other two, but it does work here because -2 is equal to -2. So that's how you can match the graph to the equation pretty easily, okay? Now, the other thing you can do is pick a particular point. And the point that I always like to pick, if I can, if they're different, is this y-intercept. You notice these are all different, all three of these points. So we're going to do the same thing, but we're going to use the point 0 and whatever this is. So that's 0 and 4, right? This blue graph goes through 0 and -1, and the green graph goes through 0 and -3. So all I'm going to do, because I use the same x value, is I'm going to plug the x value into each one of these and see which one it works. So I'm just going to plug in x equals 0 to each one. So when I do that, y is equal to 2 times 0 minus 1. So y is equal to -1. So that means 0 and -1, that's that equation. Okay? If I plug 0 into the second one, I get y is equal to 3 times 0 minus 3, which is just -3. So that means the green graph, or the green line, is that equation. And then if I plug 0 into here, I get y is equal to 0 plus 4, well, -1 times 0 plus 4, and that gives me 4. So that matches this red line, okay? So just by picking that one point, if they're all different, if you jump back here for a second, you say, why didn't you do that back here? Well, I didn't do it back here because they all actually have the same y-intercept. So if I plug 0 in for x, I would get 0 on all of them. So that's not a point that I can use because they're not different. So basically, you want to pick an x value, okay, where they're all different, and just plug that x value into each one. All right? So same thing here. And again, I'm going to use x equals 0 because the y-intercepts are all different. This is 0 and 3. This is 0 and 0. And this is 0 and -4, it looks like. And again, you might be saying, well, why are you using 0? Well, the reason I'm using 0 for x is simply because it's a nice number to plug in, because it makes things easier. You can use whatever x value you want. I could use this x value, right? Because these go through different values here, here, and then down here, right? So I could use -3, but it's just easier to plug in x equals 0. So I'm going to plug x equals 0 in, and I'm going to get y equals -3 times 0, so that gives me 0. So 0, 0 is the green line, so we're going to match it to that one. Then if I plug 0 into here, I get y is equal to -4, because this x part is 0, and so that leaves me with this green line, I believe. Sorry, not the green line, the red line. I wrote 0 minus 4 over the green line, but it's the red line that actually goes through 0 minus 4. And then if I plug 0 into this one, I just get 3 because x goes away, right? Because it's 0. And so that is the blue line. So that's how we match the equation to the graph. It's a relatively straightforward setup. And there are some questions in your textbook that I will leave for you to practice. Okay? And you can pause the video if you want to and just look at them. But there's 2 pages of practice there for you.